Assalamu alaikum. Today we'll talk about lecture 13. In lecture 13, we'll talk about the session beans life cycle, the timer service, authorization, and transaction. Session beans, you saw in the last lecture that there are 3 types of session beans. Stateful, stateless, and singleton session beans. Today we'll talk about the life cycle of the session beans. The 3 types of session beans, they have in common 2 obvious phases in their life cycle. This is when we create the session bean or when the session bean is destroyed. So the creation and destruction, all of the 3 types of session beans, they go with these 2 states, creation and destruction. But for a stateful session bean, since it is a stateful and it should keep it must keep data through a session, then it has another state called passive state. And hence, the stateful session bean will go through another 2 phases called passivation. It means which will pass to passive state, and activation, when we activate the passive bean and to become ready to invoke its methods. So we can consider stateless and singleton beans because they have only 2 states or 1 state which is ready. Stateless and singleton, they don't maintain conversational state like in the stateful session bean. So they don't maintain conversation state with a client. So both beans allow access by any client can call a request a method from a stateless or singleton bean. For stateless, it does this per instance basis because we may have more than 1 instance of a stateless bean. In fact, the container will create a pool of instances. And whenever a client requests a method from this stateless bean, the container will delegate 1 instance from the pool to execute the command or the call of the client. So for stateless, calling the methods in a bean's methods will be done per instance, while for singleton, as you know, what do we mean by singleton? It means only 1 instance of the class can be instantiated for the whole application. So, and we may have many clients calling the same singleton bean. So in this case, the container needs to maintain concurrent access to the single instance of the singleton class. Both, they share the same life cycle as shown in this figure. So before it exists, initially it doesn't exist. When a client wants to use an instance of a stateless or singleton bean, or stateless, let's say. So the life cycle starts when a client requests a reference to the bean through either dependency injection. So as we'll see in the lab, so we injected an enterprise Java bean inside a servlet. So this is what we call dependency injection, or using Java naming and directory interface lookup. Sure, for singleton, it will start maybe eagerly at the beginning at deployment of the application, as we'll see soon. Or when it is called, so it will be, one instance will be instantiated. So in all cases, when a stateless or singleton bean wants to create a new instance, the container will create a new instance. Then if there is any dependency injection inside the bean, so the container will execute the dependency injection. So if you are injecting another session bean or whatever, it will create an instance of that injected object. Then we'll call any method annotated with a post construct. Usually this is done for initialization. Then we will say that the bean is in the ready state, waiting for calls when the client call method of that bean. At the end of its life cycle, when the object or when the container wants to get rid of the instance, so before destroying the instance, the container would call any method with annotation pre-destroy. Usually we write method and we annotate it with pre-destroy, and we put in it anything to release resources that are held by the bean, or to do some cleanup in in our application. So these are the states of both stateless or singleton. Initially, they don't exist. When we want to instantiate an object of the bean, so it will go through, the container will go through these three steps consecutively. So first it will create a new instance, then do the dependency injection, then call the method with annotated post construct. Before destruction, it will call the method annotated with a pre-destroy. Even though there are many things in common between the stateless and singleton bean, but there are some differences between the two in the way they are created or destroyed. This is what we said before. For stateless bean, stateless session bean, the container would create a pool of instances of the bean and put them in a pool. When a client requests a method of a stateless bean, so the container would delegate one instance in the pool to execute the request of a client. We call it delegates. So that instance would execute the request of the client, and when it is done, it goes back to the pool. So it will be used another time for different clients. While for singleton, we have only one instance. And if the singleton session bean, we annotate it with startup, this is what we call it eager. So it will be instantiated eagerly, which means that when the application is deployed to the server, directly the container would create an instance of this singleton bean. The singleton bean would remain active or in a ready state, waiting for client's request until the server shutdown or we close the application or undeploy it. If we don't annotate it with a startup, then an instance of the singleton bean will be created whenever any business method call is done by a user. So it will instantiate the instance of a singleton. We said it has another state called passive state. Why? Because session bean maintain connection or conversation with clients through a session. So what happens if the client is idle and is not using this stateful bean? So what will happen? The server cannot keep the bean in memory and waste space or resources, because we may have thousands of clients. So the solution is to send this stateful session bean to passive state, which is held on a storage, not in the main memory. So now we have another two phases. So we have with passive. So when the stateful bean is in ready state and it is not used, it will go to passive state, and we call it passivated. So before it goes to passivated state, so the container would call any method annotated with pre-passivate. Again, maybe to release any resources held by the bean. Because if we have, for example, a connection to a database server, we don't want to keep this connection while the client is idle. Same, when the client again requests a method of this session bean, the container would call the post-activate method, method annotated with post-activate, and then it will and put it in memory for use and execute the methods of the bean. So this is the third state for stateful bean. And we have now another two callback annotations, one pre-passivate and one post-activate. When the session bean expires, we have a session timeout. We specify what is the timeout of a stateful session bean. We can write this in the deployment file. So if we put, for example, this timeout is 30 seconds or maybe 1 minute, if that time, that period of time expires and the client is idle, the session would be terminated, and any session stateful session bean will be destroyed. But the container, before destroying this stateful session bean, it will call the pre-destroy method, a method annotated with a pre-destroy. Sometimes we want to terminate the session bean. We may annotate a method with remove. So when that method is called, it will remove the stateful session bean. So this is the life cycle of a stateful session bean. So it starts when a client requests a reference to the bean by either dependency injection or GNDI lookup. So the container creates a new session bean. Here we are talking about stateful session bean. Same as the stateless and singleton. So first, if the session bean, which is stateful session bean, again contains a dependency injection, so the container would execute any dependency injection. So it would create instance of the object injected in that bean. Next, it will do the post construct, because they are common with for stateful session bean, similar to stateless and singleton, in the sense they call the post construct and pre-destroy. Then the bean would be in the ready state. If the client remain idle for some time, so to free memory and make efficient use of resources, the container would pass it to the wants to send it to storage, not keep it in memory. Before sending it to storage, hard disk or whatever, so it would call the method pre-passivate. Then the bean, the stateful session bean, would be in the passive state, waiting for a request from the client. When the client invokes or requests a passivated bean, the container would activate it back to memory by first invoking the post activate and then execute the method of that bean. As we said, if the timeout of the session expires, we specified a time for a session, timeout for a session. So the instance would be destroyed. Before it is destroyed, the pre-destroy method is called. Again, we said we sometimes, even without the timeout, session timeout, we could, or the user can remove a session instance by annotating a method with remove. So when that method is called, it will execute and finish at the end will destroy the instance. So in summary, the callbacks methods for session beans are these four: post construct, pre-destroy, pre-passivate, and post activate. Post construct and pre-destroy for all three types of session beans: stateful, stateless, and singleton, while the pre-passivate and post activate annotations are only for stateful session bean. Now, can we annotate any method with these annotation, callback annotations? We can, but there are some conditions that must be satisfied. For example, the method must not have any parameters. So the methods that we want to annotate with post construct or pre destroy or post pre post activate or pre passivate, they must not have parameters and they must return void. The second condition, the method must not throw a checked exception, but can throw runtime exception. So we may have runtime exception. For example, we are trying to connect to a database and the database connection or database server is not available. So it will throw a runtime exception. But we cannot write in our method a checked exception. The method can have public, private, protected, or default, which is package level access, but must not be static or final. It cannot be a class method annotated with or specified with static, and it cannot be final. So these are the three conditions. So the methods to be annotated with callbacks annotation, these four annotations, it cannot have parameters, it must return voids, it cannot throw a checked exception, and the method cannot be static or final. Other qualifiers can be used, public, private, and so on. The other points, can we annotate a method with two annotations like post construct and post activate? Yes. But the question, can we annotate two methods with the same annotation? Yeah, I write two methods and method one with post construct and method two with post construct. We cannot do this. This is logical. But one method may be annotated with two annotations, and which is logical, because, for example, after post construct and post activate, as we'll see in the following example, we want to, for example, to establish connection. So in both cases, we want to do a connection with a database. So we annotate the same method with two annotations, post construct and post activate. Another point is that the callback method can access the environment or environment entries through the context, they get context, and we get the information about our environment. So these callbacks, we use them again to allocate resources or to release resources instead of keeping them wasting resources. This is an example of the callbacks methods. So here we have a shopping cart enterprise Java bean. It is a stateful session bean because clients, while shopping online, he needs to go from page to page through different requests and add items to his shopping cart. So if we created a shopping cart as a stateful session bean, so this shopping cart bean, first of all, what do we need to save? We want to save the items that he selected from the inventory. So we need an array list, let's call it cart items. So this is a list of items. So whenever the client go to a page and select an item, the item will be added to the cart items. The cart items, this array list, is transient. It means at the end, we don't save the cart items in the database. What is saved in the database is the order and order details. So this cart item is a transient. So we need it while the customer is shopping around our website, the website. So in this case, we will we need to connect to get information from the database. We need a connection to a database. So in this case, let's write a method called initialize in it. So it is return type is void. It doesn't take parameters, and we annotated with two annotation: post construct and post activate. So in this case, what we will do here, we have a data source called ds. We have a connection. So a data source is a resource. We use GNDI to specify this data source. It is the default data source. This exists connection with a Derby database. And this is a connection object. So after construction or after activation, what we want to do, we want to get a connection from the data source. So we use ds.get connection. So in both cases, after construction or after activation, we want to establish or to reestablish the connection with the database. So we call the ds.get connection. What about when you want to close or when you want to session bean will be destroyed? So we write a method called close. We annotated with pre-passivate and pre-destroy. So before going to passive state or before destruction, this method will be called. What we need to do in this, we want to clean up and release resources. What is the resource that we have now? We established a connection to a database. We want to close this connection. We don't want to keep the connection with the database while we are not using it. So in this method, we write one statement to close the connection. Notice here, the same method we annotated with two annotation. This is okay. But we cannot write two methods and annotate them with the same annotation. Finally, the method checkout. A checkout annotated with remove. So again, when we say remove, we want to clear the list of items. So we say cart item.clear, and then the pre-destroy will be called. Again, the connection will be closed. So this is a simple example about using the callback methods in session beans. The second point in this lecture is the timer service. Timers are very important. Why? Because sometimes we need to do some task we want to schedule some tasks to be executed at specified time or in some duration after some interval of time. So sometimes applications need to schedule tasks. For example, at the end of the day, I want to produce a report of the sales of an employee, or at the end of every week, I want to produce the weekly sales and so on. So these tasks must be scheduled to be executed automatically. I don't want an employee to go and produce these reports manually. So the timer is an important part in Java Enterprise Edition. So the Enterprise Java Bean timer service is a container service. So it is done or provided by the container of the EJB, Enterprise Java Bean. For callback invocation, it will call which methods. Don't forget them with those post construct and pre-destroy callbacks. Callbacks, it means this is the method that will be called after some interval of time. So the Enterprise Java Bean notification, the methods in the Enterprise Java Bean may be scheduled to occur according to a calendar-based schedule, like do it at the beginning of every month, at a specified time, every day at 5 o'clock, after a specific elapsed duration, after 5 days, or at a specified recurring intervals, like execute one method every hour, You want to back up every hour. So we said the timer service is maintained by the container. So the container will have keeps records of all the timers, and after the elapsed time or after the timeout, it will call the appropriate methods of that bean. So what will happen when we have a timer service? For example, a session bean requires a timer. The timer could be used either automatic or programmatic. In the lab, we saw automatic timer service using the annotation schedule. You will see in this is an example in lab 13B. Or we can use programmatic registration of timers. So in this course, you don't have time to cover all aspects. So we saw a simple example about using automatic timer service in the lab. So this is very simple. You just annotate a method with schedule annotation, and you can specify at what time or what day or at specified interval with that one. So the session bean may use the timer service using automatic or programmatic registration. Now, when the session bean register a timer service, the container, when the time out happen, it will notify the bean about the timeouts and invoke the methods annotated, for example, with the schedule. So timers are intended for long-lived business processes and are by default persistent. So they are not transient, they are persistent. So once you create a timer service, it will run while the application is running. This means they survive server shutdown. What does it mean? Even if there is you close the server, stop the server. When the server starts again, the timer server will resume when if the application is deployed. Sure, if you don't deploy the application, the timer service doesn't exist. So once the server starts again and application is deployed, waiting to be called, so in this case, the timer service resume. It means if you schedule a task to run at 5 o'clock, if there was a crash at 2 and the server resume at 4, it will execute the method again at 5. So this is the second point of this lecture. After session bean life cycle callback methods. The second point is the timer service. Quick idea about this. The third point is authorization authentication and authorization. Again, this is a big area in Java Enterprise Edition, because all web applications need to be secured. So you need to have authentication and authorization and security between connection. So most real life applications, they need a bit of, or a lot of security. In these few slides, we'll have a just quick idea about authorization and authentication. So first, the authentication is handled by the web tier, because we may restrict the access to our pages or to our resources in our web application to specified users, to registered users. So in this case, when we have like this, so which part of the multi-tier application will be responsible to allow the authentication? The authentication is done, sure, by the front level, which is the web tier. So it will check the principal. Principal is a technical word. As you saw in the server, we create users and the groups. When the user log in, we call it inside the web application, it is called the principal. And inside the application, we call the roles, and we maps the roles to groups, or we may have default mapping if we have the same name. The principal and the roles are passed then to the business logic tier, which is the Enterprise Java Bean tier, the middle tier. And here now it comes the authorization. So the authentication is done by the front tier, which is the web tier or the client tier, while authorization is done inside the middle tier, which is the Enterprise Java Beans. For example, we may create an Enterprise Java Bean and allow some users to use some methods and other users to use different methods. So this is what we call authorization. For example, an admin is authorized to use delete method, while a normal user is not authorized to use delete methods. So this, we use them declaratively or programmatically inside the Enterprise Java Bean. With declarative authorization, access control is made by the Enterprise Java Bean container. So who manage the authorization is the Enterprise Java Bean container. We'll check if a user or principal is allowed to use one method or not. If yes, the method can be invoked. Otherwise, it will tell the user that you are not authorized to use this method. This is done using the technology in Java called Java Authentication and Authorization Services. Declarative authorization, and this is what we use in the lab. We declare roles and assign permission to methods, to roles of some methods. We use some annotations like permit all. The annotation at permit all, we can use it on bean or on a specified method in a bean. And it's clear what's the meaning. Permit all roles. Deny all roles. Roles allowed if you want to specify for a method or for a bean or a method to use a specified roles. So we use roles allowed. Declare roles annotation is used only for bean. We define roles for a bean. Same run as is a annotation for the bean only. You cannot use it on a method. When we annotate a bean with run as, for example, if a user is logged in as a guest, and I want to allow him to access some bean, usually it is done the vice versa. Like one is logged as admin, and I have a bean where I want to admin to run as a guest. So we annotate that bean as run as the role guest. So these are some of the annotation used for security. In the lab 13A, we have used roles allowed, and in the enterprise Java Bean, we use roles. We use declare roles, and we use roles annotated. So this is the declarative authorization. Again, as I said, there is programmatic authorization, but we cannot cover everything in these few slides. In that, it is good to read if you want to develop real-life application with Java Enterprise Edition. You must read the 4 chapters on security in the Java Enterprise Edition 7 tutorial. There are a whole part on security with 4 chapters talking about all the aspects of security. So this is an example about using security annotation. So in this case, we have an item bean called item enterprise Java bean. It is a stateless bean. So if I want to allow different roles to use this bean, so at the beginning we annotate with roles allowed. Here, users can use this one. Employees can use. Admin can use this one. But inside, we have this method, find book by ID. This method could be used by all roles. So we annotate with permit all. While, for example, for deleting a book, this cannot be done by a user or cannot be done by an employee. So we annotate this method with roles allowed admin. So even though the 3 roles can use this bean, only the admin, users with role admin can invoke the method delete book. So this is how we annotate. We use declarative security on beans. Remember, this is for authorization. So any user with role admin is authorized to use this method, while the remaining roles, employee or user, cannot use this one. While for this method of the bean can be used by all. Here we declare roles, HR and sales. So we are declaring a new roles. Programmatic authorization, quickly. If I want to write in my beans, session bean, to allow some users to access or to save information about who is accessing what, we may use programmatic authorization. For programmatic authorization, in the session context, we have 2 methods. When you get context, you can get who is the principal by calling the method getCallerPrincipal. They will return who is logged in, which user is logged in. So we get the information about the principal using this application. And also there is another method called isCallerInRole. So we may use these methods of the session context to see if the user logged into this application have a special role to do something. So in this case, delete book. Consider the delete book. If instead of allowing only admin, in this case, I want to see if it is admin and I want to write here just to check that the user removing or deleting the book calling this method is admin. So if this is the get context, session context, is caller enroll admin, then it can delete. Otherwise, if he is not in the admin, it will throw a security exception and it will tell the user only admins can delete. Another use for get caller principal. If I have a log file and I want to information about who is deleting, I want to write information about who is deleting to write it in or modifying something in a log file. Again, here the second important method of the session context called get caller principal. So get caller principal dot get name, it will give you the username of the users who is logged in, and I can write it in a log file, or I can check if he is a special user or whatever. So these two methods are used for programmatic authorization. These two methods are in the session context, and this is a simple example how we use them. Finally, we'll talk about the last topic, transactions. You know transactions from database management system. In database management system, transactions are very important topic in database management systems. Why? What you learned there? You say set of operations that must be done altogether or aborted. For example, if I'm transferring money from one account to another account, what does it mean transfer money from one account to another account? We want to debit one account and then credit another account. Suppose while doing this, these operations, I debited the first account and then there was some crash. Do we continue? So one account has debited 100 riyal and the second one doesn't have credit. So in these cases, debit and the credit, or these two, and maybe writing to a log file, these three operations must be written in one transaction. So either they must be done altogether or aborted. So what about transaction in web application? We cannot rely only, even though there is a transaction management in the database management system, but also we want to maintain transactions in the web application. That's why the transaction also is a Java JTA is a technology of Java Enterprise Edition, and it is an essential part technology of Java Enterprise Edition. So using transaction in web application is used to ensure data are kept in a consistent state in the application. Remember, transaction management also is done in the database server, but we want to keep our data consistent in our application. It represents a logical group of operations. So what is a transaction? A set of operations that must be either done altogether or nothing is done. We cannot execute it partially. So we consider it as a single unit. So every operation must succeed. So if we have four operations task inside our transaction, if all the operations are successful and we reach the end of the transaction, then and only then the transaction will be committed. If something wrong happened, it will be rolled back. It means any work done before, any operations that executed before the crash, it will be reverted. Transactions must guarantee a degree of reliability and robustness, and a transaction follow the asset property. Again, you must have seen this, the four properties that must be followed by transaction. A represent atomicity, C consistency, I isolation, D durability. A definition similar to what you saw in database management system, but now we are talking about application. So what does it mean, atomicity? It means all the operations are taken as a single unit. Atoms was used to be the single the basic unit of the matter. Consistency. So what does it mean, consistency? The transaction would move from the application from a consistent state to a consistent state. In between, there may be some inconsistency, but before the start of the transaction, the application must be in a consistent state. And after the execution of the transaction must leave the application in a consistent state. What I mean application, it means the data in my application. Isolation, what does it mean? We may have many clients using different transactions. That execution of one transaction should not interfere with the execution of another transaction. This is what we call isolation. So it means that transaction must, as if it is done in isolation with the remaining transactions. Durability. What does it mean, durability? It means after the transaction is committed, the changes are permanent. They persist. Again, remember, this is what we are talking about, transaction in the web in the Java Enterprise Edition application. Again, it may use the transaction of database server, but this is inside our application to maintain the data in our application in a consistent state. So these are the four important, we call them asset properties, that must be followed by must be maintained by a transaction. So atomicity, consistency, isolation, and durability. Java Transaction API, local transactions. You saw transactions in the previous lectures and labs, how we create a transaction, how we begin a transaction. If we created a transaction, we use begin to begin a transaction. We write our operations, like let's say we call different methods, debit, credit, and so on. At the end, we write commit. If something happened during the execution of this transaction, the transaction manager will roll back all the operations done and will take the data or the application to the consistent state before the transaction started. So the transaction manager will communicate with the resource manager, and the resource manager will control the results. So transaction manager is the core component responsible for managing, from the name. It is the manager of the transactions. It creates transactions on behalf of the application. When you use, when you create an application, it informs the resource manager that some transaction, they need some resource, and conduct the commit and rollback. So this is the role of the transaction manager. When a transaction requires a resource, so the request will go to the resource manager. Resource manager will register which transaction wants which resource. For example of a resource manager is a driver to connect to a special relation database server or Java connector. A resource is, for example, connection with database. This is the resource. Transaction specifications overview. Finally, transactions JTA API consists of classes and interfaces grouped in two packages. We have transaction in JavaX, and we have transaction.xa in JavaX. What is the difference between the two? The one for normal transactions, transactions run on the same server, and one for distributed transactions. Remember, sometimes we have distributed databases, and sometimes we have a distributed transactions, transactions that will run on different servers. So the classes for JTA API are in these two packages. Finally, you used to create transaction. The final one, if we declare, we can use the annotation transactional. What does it mean, transactional? So if someone called this get all books, so the transaction manager would create a transaction and will run this method in a transaction. So if something happened inside this method exception, it will roll back. So it will take it as it will roll it back to the consistent state before the transaction started. And this is the end of lecture 13. Thank you for listening.